The first topic of organic chemistry, the crude oil and the fractional distillation of the crude oil. The definition of fossil fuel, how we define what is fossil fuel. So basically the organic matter which was once living, example coal is from dead plant matter, and oil is there, it's from dead sea creature remains such as planktons. So fossil fuel is the organic matter which was once living. Coal, oil, gas, these are all examples of the fossil fuel. But what is the crude oil? Actually, crude oil is a mixture of different fossil fuels. We call that as a crude oil. So it is made up of hydrocarbons, compound which contain carbon and hydrogen only. These compounds are present, and it is a result of heat and pressure on a plant or a sea animal which remain over a billion years in the absence of air. For example, how this, like how a plankton converted into the fossil fuel. So basically, at the surface of the sea, the microorganisms such as planktons, when these organisms die, so they will move towards a seabed. So as they move towards the seabed, so these organisms covered with a layer of rocks and sand, and this rock and sand, it does not allow them to decay. Why it does not decay? Because for a decay they need oxygen, but oxygen is absent, or in the absence of oxygen, if oxygen is not there, what will happen? After millions years, this will turn into a fossil fuel. So this is the formation of the fossil fuel. So this is the formation of a fossil fuel, and in this formation of a fossil fuel, you don't have to learn how it is formed. You have to learn the extraction of a. You have to learn the extraction of the crude oil, or how we separate the different oils from a mixture. So the crude oil, which is a mixture of a hydrocarbon, different hydrocarbon, this result in a formation of heat and a pressure on a plant or the dead sea animals, which remain over a period for millions years in the absence of oxygen. This will result in a formation of oil and gas. Then the important topic, the first topic of this organic chemistry, how we separate the components present in the crude oil, because crude oil is a mixture of different hydrocarbon. So we use fraction distillation of the crude oil, how we carry out this. A superheated, here the crude oil, it's about 450 degrees centigrade, above 450 degrees centigrade. It enter the fractionating column. This is a fractionating column. What happened, like example, if I say there are fractions present in the crude oil A, B, C, D, E, and F. So different fractions are there in the crude oil. Some of the fraction, even around 450 degrees centigrade, are still in a liquid state. So the fraction which is still in a liquid state will move out the fractionating column from the position where we enter. It leaves out from other side. So superheated crude oil around above 450 degrees centigrade enter the fractionating column, but the fraction which still is in a liquid state, which is also known as a residue, or we call a bitumen, which is used to make roads and the roofs. What happened to the other fractions? The other fractions will rise. So there are other fractions in the crude oil which are rising. But as they rise, the other fraction rise, they lose their energy. So when they lose the energy, it will condense and convert into liquid state. So some of the fraction, if converted into liquid state, the other remaining will rise. Then further condenses here, remaining will rise, condenses at this point, remaining will rise, condenses at this point, and the last part, which is not converted into liquid state, will remain in a gaseous state. So basically what happened, a mixture of oils or different fuels, which is including a fuel oil or a diesel.
So crude oil is solid or liquid?
Crude oil is a liquid which it's a basically a mixture of liquid, not only it's a mixture of liquid, and it also contains dissolved gas, which is refined gas such as propane and butane.
So what
So
do you mean by condensing?
condense means change from gas or vapors to liquid, because we heat the crude oil, so it contains different fractions. What happens as these fractions are rising, they are losing energy. So when these fractions are losing energy, they convert into liquid state. So at different temperatures, you obtain different fractions. For example, residue is there. Residue is a fraction which is not converted into a gaseous state. So when the crude oil enter, it is still in a liquid state, the residue, so residue will escape from the bottom. What happened to the other fractions, other parts which are or component which are present in the crude oil, they start to rise up because they are in a vapor form. But as they are rising up, some of the fraction condenses. So the part of the fraction which condenses first, that part is called a fuel oil. So it is in a way, most fractions when they're entering, they're in a vapor form, but as they're rising, they're losing energy. As they lose energy, they condense and turn into liquid. So at different temperatures, we have different fractions converting into liquid state. And some of the fraction is not converting into liquid state, it remains gas at room temperature, which is about 25 degrees centigrade, known as the refinery gases. So what you have to do, you have to learn this label for a fraction distillation of the crude oil. So we add a crude oil enter, a liquid fraction will escape. But what happened to the other fraction which are in a vapor form or a gaseous form? They will rise up. As they are rising up, they lose the energy. So fraction at different temperature condenses, and eventually all of the fractions are separated from each other. So when we separate the substance on the basis of the boiling point, we call that as fractional distillation. Is it clear? This is a fractional distillation of the crude oil. So you have to learn these labels. With the uses as well. So fraction distillation, the process which is used to separate the mixture of a liquids which are having different boiling points. So when heated, the liquid with a low boiling point will evaporate and turn into vapor and can be separated. So those with a high boiling point will remain in the liquid state. So when we compare the boiling points, which one you think will have the higher boiling point, the bottled water or bitumen? The bitumen will have the higher boiling point. And what we observe here, the trend, as the boiling point is, the boiling point of a hydrocarbon is directly proportional to number of the carbon atoms. Greater the number of the carbon atom, higher the boiling point. So because Bitumen is having the higher boiling point than compared to any other fractions. So that is why bitumen is having the highest carbon number. Whereas refinery gas, because it is having a low boiling point, still it is a gas at room temperature. So it shows that the carbon number or number of the carbon is small here. So higher boiling point means the hydrocarbon contain more carbon atoms, and lower boiling point means the hydrocarbon contain less number of carbon atoms. When we compare the molecule, so as we go down, what we observe, the molecule will be larger, the boiling point will be higher, volatility decreases. What does volatility means? Like can easily, if something can easily convert into vapor, we call that as a volatile substance. So volatility decreases, it means it cannot easily convert into vapor. Does not flow easily. As the higher carbon number, the fraction become viscous. So as it become viscous, it means it cannot flow easily, thick or a viscous, and does not ignite easily because lot of carbon atoms are there. You need plenty of oxygen to burn them, so you cannot burn them easily. But higher the fractions which you obtain at the top, because they have a small molecule, so they have low boiling point, they are volatile. Volatile means can easily convert into vapor, as small number of carbons, so they can flow easily and you can burn them easily. Any doubt in this fraction distillation of a crude oil? This topic, fraction distillation of a crude oil, is given in energetic topic as well, but main thing is in organic chemistry. It is given in energetic chapter as well, but because these are all the fractions are organic compounds, hydrocarbon, so in organic chemistry you will learn this. So as the number of the carbon increases, what we observe, like we observe the boiling point increases, we observe they are less volatile. Less volatile means can not convert into vapor easily, and difficult to flow, and difficult to ignite because you need lot of oxygen to burn them. So if I say which fraction is having higher carbon number, gasoline or petrol or diesel, which is having greater number of the carbon?
Diesel.
Diesel will have more carbon as compared to gasoline. Which substance will produce more energy when burned completely? Which one you think will produce more energy when burned completely?
Diesel. Diesel.
Diesel, because it contains higher carbon number, so it release more energy. That's why the buses, lorries, they are using a diesel engine rather than petrol engine, because a diesel when burned completely produce more energy as compared to petrol. Why carbon atoms are more useful as compared to large number of carbon atoms? Like bitumen is not having more uses, like it can be used for road carpeting, but you don't find many uses for bitumen. But the hydrocarbons which are having a small number of carbon, they have many uses. So what we prefer to have a hydrocarbon with a small carbon numbers. So for this purpose, what we do, we use a technique or a method, and this technique or a method is known as cracking. So basically, what is the meaning of a cracking? When I say you crack an object, it means you break an object. So in a cracking, what we do, we take a long chain hydrocarbon and we break this chain of a hydrocarbon. So as we break this chain of a hydrocarbon, what will happen? It will break into smaller hydrocarbons. So as it will break into smaller hydrocarbon, Smaller hydrocarbons have more uses as compared to long chain hydrocarbon. That's why cracking is an important process which is done for these hydrocarbons to increase the number of small hydrocarbons. In this diagram, we have a crude oil which is a mixture of different components. It consists of residue, a bitumen, it contains a fuel oil, it contains diesel, it contains kerosene or paraffin, it contains naphtha, it contains gasoline or petrol, and it contains refinery gas. So what we do, we heat this crude oil. So when we heat this crude oil, most of the fraction, because the temperature of this mixture is higher than the boiling point of most of the fraction, so most of the fraction, when they enter the fractionating column, they are in a gaseous form except bitumen, which is having a boiling point higher than the temperature of the mixture. So bitumen is in a liquid state, and as it is in a liquid state, so bitumen is removed from the fraction at first. What happened to remaining fractions such as fuel oil, diesel, kerosene, naphtha, gasoline, or refinery
So,
gas?
sir, before the crude oil enters, all of it is liquid.
No, you mean before heating it? Before
Yeah,
heating,
before entering the column.
yeah, before entering the column, it is a mixture of liquid and gas. It
Yeah.
contains a dissolved gas, refinery gas, and it contains it is having liquids. But when we
All
supply heat energy, almost all, or except bitumen, all of the fractions are in a gaseous state. So all the fractions will rise. As the fractions are rising, they lose energy. So as they lose energy, at their boiling temperature, they will condense. Condensation means when a vapor change into liquid. So first one which condenses is the fuel oil, but remaining fraction will rise. As the remaining fraction are rising, they'll also lose energy and condenses. So the second fraction which condenses is a few diesel oil, then remaining fraction will rise. Then the third one which condenses is the kerosene oil, then remaining fraction will rise. Then naphtha will condense, then remaining fraction will rise. Gasoline will condense, and the fraction which does not condense, that is called a refinery gases, or it's a mixture of butane and propane. So at different temperatures, as we go down, as the molecules are rising, they're losing energy, so they condenses at different temperatures. Why the gases are rising? As you studied this concept, when something is hot, the molecules tend to move away from each other. As a molecule tend to move away from each other, so volume increase, so density will decrease. So hot molecules or a fraction which is having a high temperature will rise. But as they're rising, they're losing energy. So molecules are coming closer to each other. At different temperatures, the molecules will change in their state into like come together and close together and form a liquid state. Is it clear? So this is an important topic, the fractional distillation of the crude oil. So what is petrol? Petrol is basically octane, means it contains 8 carbon atoms and all have a single bond. So gasoline or petrol is a common name, but the IUPAC or the standard name for petrol is octane. But if you say like go to any petrol station or a gas station and you say fill my car with octane, he will not understand because that's a standard name, IUPAC name. So he understand the common name, that is petrol or But if sometime it's also saying add benzene, that's also wrong. Benzene is another thing. Petrol and benzene are totally different thing. Benzene means 6 carbon atoms in a ring. You will learn in A levels the structure of the benzene. This is the structure of a benzene. So it should not be benzene, it should be petrol or gasoline. But that benzene, when it's written like it's a benzene station, it means they're not using a standard name, they're using a common name. So instead of saying petrol, they're saying benzene. Is it clear, the fractional distillation of the crude oil?